We're trying to figure out the net force for this particular question. You need to figure out the vector representation, magnitude, and direction. All the three things I want. So you guys can take a second, try it. Okay. To solve any kind of question which deals with vectors being in different directions other than one in one dimension, right? In two dimension, if we have such vectors, we need to resolve them, right? So we'll start off by resolving, say 20. So we have 20 somewhere over here, and we have over here. So this is, by the way, the original 20. And this is your original 10. And this we have 6. So this is your 10, and this is your 10 being resolved, and this is your 6. So 6 Newton. This will be 10. This is adjacent side, so this will be cos of 37 degree. This will be 10. This has to be sine of 37 degree. And this is 20. This would be, this is cos 37, and this is 20 sine 37. Okay, so we have all of these. Now they're working. So let's figure out all of these forces. In their vector form, right? So that's what we are at. We have 20 cos 35, that's 0.8 I cap negative, plus 20 into 0.6 j cap positive. So many Newton. Then we have F2. So that would be, F2 is where, this is my F2. So both are negative. So we have 10 into 0.6 I cap minus 10 into 0.8 j cap Newton. And we have F3, which is 6 minus 6 j cap Newton. Oh yeah, by the way, up and right is positive for me. And now F net, which is sum of all the forces acting on the object, is given by minus 16 I cap plus 12 j cap minus 6 I cap minus 8 j cap and minus 6 j cap. I is over here, I is over here, and we have this to be minus 22 I cap, and we have j here, and we have this to be minus 2 j cap. So this is in third quadrant. And now the angle. Oh, sorry, the magnitude and then the angle. So magnitude would be 484 plus 6 plus 4. So root of 488. This is 22.1 Newton. And in terms of direction, theta will be tan inverse of 2 by 22. So tan inverse of 11. 1 by 11. This will be 5.2 degree. So basically it would be 5.2 would be something like this, but since it's in third quadrant, it will be pointing this way. So your graph would, resulting vector would look something like this. We have, say, 5.2 will be somewhere over there. So your resulting vector would point in this direction. This is 5.2 degree and this value is 22 point Newton. So that would be your answer. Okay, then what else? Yeah, we are done. So does that make sense? That's one thing that I keep asking. So it makes sense. You have a force which is decent, not too much. No, 20 times of sine 37. So that's pretty good value. And it does cancels quite a bit of the downward pull. Does it though? Did I do any mistake? J minus 8 and minus 6. Cos 37 is 0.8, but it's 10. Because of that, this is 20. Okay, left, there is plenty of pull to the left. Actually, everything is pulling to the left. These two forces are pulling to the left, so they'll add up. So it makes sense. There's a lot of pull to the left than to the right. And so you have 22.1 Newton somewhere pointing that way. Okay,